let's return to our example earlier of me owing you money. And let's say it so happens that the mutual clock drift is 5 between you and me. So my clock, when it reads 3 p.m., your clock reads 8 p.m. So that is the mutual clock drift that we have. And let's say that the inter-process communication time, the lower bound on that is 2. So what happens is that, as I told you earlier, I am telling you anytime after 5 p.m., you can get the money from me, from my bank. And so you instructed your bank to debit at 8 p.m. But unfortunately, your 8 p.m. is my 3 p.m. because our mutual clock drift is 5. So when your request went out, took 2 units of time to get to the server, went out, and the central bank got your message asking for a debit transaction, but the credit is not there yet because I'm waiting till 5 p.m. to actually send my credit advice to the bank. And therefore, your request, which came in at 4 p.m., because you sent it relative to me, you're 5 hours ahead, and in terms of real time, you're actually 6 hours ahead. And so the message is received at 4 p.m. and your request is declined. And this is coming about because of the fact that your inter-process communication time, mu, is less than the mutual clock drift that we are seeing between these two clocks, which is 5. On the other hand, if the mutual clock drift is less than the inter-process communication time, so in this case, let's say that the clocks are more well-behaved, epsilon is 1, meaning the mutual clock drift between you and me is just 1. And so exactly the same scenario, when it is 3 p.m. in my branch, your branch is saying your time is 4 p.m. Of course, you've given the advice to your branch to debit at 8 p.m. So at my local time, 5 p.m., I send a credit advice received by the bank. And at your time, 8 p.m., which is not quite in sync with real time, and it is also drifting with respect to my time, but the bound is less than the lower bound on the inter-process communication time, and therefore, when you send your debit request at 8 p.m. your local time, which actually is real time 6 p.m., it's perfectly fine because when it is received in the central bank, the real time is 8 p.m. and it is received later than the credit request, and so your request is honored, you're happy, and you can go home. So the important takeaway is that in constructing distributed applications which depend on real time, it is important to make sure that there are bounds on individual clock drift as well as mutual clock drift. So individual clock drift is what my clock is reading at any point of time and how far off is it from real time. So that is individual clock drift. And you want that to be bound by some small value which we call k. And the other important thing is that you want to make sure that the mutual clock drift is very, very small also, so that there is no anomaly when there are interactions like what we showed here. And the whole thing hinges on the relationship between mutual clock drift, the individual clock drift k, and the inter-process communication time. Informally, so long as you make sure that the inter-process communication time is significantly higher than the clock drifts, whether it is mutual or individual clock drift, you can ensure that there are no anomalies in the system.